Hello everyone. On this video we will be taking a quick look at how to spot symmetry in polar curves. Okay, so first let's say if a polar equation is unchanged when theta is replaced by negative theta, then the curve is symmetric about the polar axis. Okay, so if we get our equation and we plug in, we have r equals something theta, and we replace that theta with a negative theta. So let's say instead of pi over 2, we replace it with negative pi over 2, and it comes out to be the exact same answer. Then we know for any theta, not just one particular theta, but it has to be for any theta. Then we know it's symmetric about the polar axis. So how that would look, okay, we have our x and y axis. So let's say if our graph looks like this, the thing looks like this here. Now this should be a little bit higher, or a little bit lower. Trying to keep it to looking completely symmetric. Okay, so let's say this right here is an example of your r theta. Then you should have an r negative theta, okay, on the graph also. Okay, so really this is very, very similar to being symmetric about the x-axis. Being symmetric about the x-axis in rectangular coordinates. Okay, so if you understood how to solve for symmetry about the x-axis, this is basically the same thing. Okay, so if you're a little rusty, you can go to my video for symmetry and intermediate algebra, and it will go over that to kind of give you a brush up if you need it. Okay, so let's say for an equation, let's say if the equation is unchanged when our r is replaced with negative r and theta is replaced with theta plus pi. Then the curve is symmetric about the pole. Alright. So, give you a quick visual. Let's say if you have a graph that looks like that, something like that. Okay, so let's say this point here, let's say this is your r theta. And let's say we keep going to this point here. Let's say you have negative r theta plus pi. Okay, so if that's the case, both of these points should appear on the graph. Okay, so for every r theta, negative r theta plus pi puts you on the curve, then you know it's symmetric about the pole, or in this case, it's similar to being symmetric about the origin. Okay, similar to being symmetric about the origin in rectangular coordinates. Okay, so we have one more. Oh, if you are still writing, feel free to press pause. Right. Now let's say if the equation is unchanged when theta is replaced by pi minus theta, then the curve is symmetric about the vertical line. Theta equals pi over 2. Okay, so to help you visualize that, go ahead and draw our axis. Okay, so if we have our theta, the point should also exist where you have an r pi minus theta. Okay, so this is really similar to being symmetric about the y-axis. In rectangular coordinates. Okay, so those are just the general ideas behind symmetry of a polar equation or polar curve. All right. Again, I promise you it was a really quick video, so hopefully this made sense, and I will see you on the next video.